Okay, if you remember last class, we're going to talk about chapter 1.5 today, not 1.6. Sorry about that. Okay, in last class, we talked about that basic shape of a parabola, which we can get if we were to graph all the points of the function y equals x squared. Or now that we are in functions and applications, I'm going to write it like that. If I plug in any x value of x, or any value of x, and calculate the y, you will get all of these points going up forever and all of these points going up forever. Oh, was that not stapled? That's my bad. Right? Oh, okay. Right. And then we talked about three different transformations. I didn't transform them, but we did talk about three letters A, H, and K that apply to a function to give us something like this. The A is in the front multiplying. The H appears to be subtracting the X, and the K is outside of that bracket. There are three numbers that you're always going to see, at least in this class. And that will allow us to have a wide parabola. It could allow us to have a wide parabola that moves to the right. And then it could give us a wide parabola that moved to the right and then moved upwards. Something like this. So this is what we started with, and this is what we finished with. Long story short, the goal of the next three sections, or the next two sections, 1.5 and 1.6, is to be able to take a regular x squared, that's here, and turn it into any parabola out there instantly. And I use that word specific, instantly. You have to practice and practice and practice until you can sketch that very quickly. I'm talking within minutes. I'm not talking like you have 10 minutes to do this one question. No, it's like graph it and then solve it. Like you have to be able to do all parts of that question in like 5 minutes or something. So let's take a look. We are going to quickly explore what each of these numbers do. So what happens if there's a number multiplying? What happens if there's a multiple number subtracting? And what happens when there's a number adding? Three different sections. And then we're going to see how we can use that and put it all together in one equation. All right. So here we go. Consider this function. Now, I purposely gave you something that looks like the Big Dipper, like a constellation, to show you that this application can happen to anything. Take a look. If this was my function and I have the points, I'll start with -4, 4. That's the first one. And it goes all this weird stuff. What else is there? We have a -2 and a 3. We have a -1, -1. That's a 3, -2. This is a 5, 1, and a 6, 1. Okay, just to show you what those points are. If you don't want to copy, you don't have to, but just these are the 6 points that are part of this function. Not a parabola, just 6 points. Every transformation that we do is going to affect either the x or the y of these points. All right, let's do this. Let's start with the easiest one. Are people still copying this? If you're still copying, I'll leave this. But while you are copying this, everyone else, I'd like you to read that line. +4, bless you, +4, -5, they are both representing one of the three letters. I'm going to bring us back. If I were to say that f of x is going to be transformed, sorry, that equals x squared, is going to be transformed into that. Take a guess. Between AH and K, What, I'm going to use some highlighters. What letter do you think I am working with here? Yeah, go for it. So I'll use green for A, blue for H, and pink for K. Which letter do you think we are talking about here? Take a guess. And I invite you to be wrong. Leanne? A K. Oh, did you say K? Okay, I didn't hear you. Sorry. The +4 and the -5 are going to be my K value. So here I'm going to say my K value is a 4. Okay? And what does that mean? Anyone remember from last class what the K actually represented? I gave you a word definition for it. If you see an addition or subtraction outside of the function, then this happens. Yeah. No. It is something about up and down, though. It is something about vertical. Yes. It moves. The proper word I want to say is it. Hi. Awesome. So I am going to take every single point. Come on in when you're ready. We're going to take every single point here and shift up by 4. What does that mean to the X and Y points? So if I'm shifting up by 4, where does that go? Up to you, really. Okay. Now might be a good time. Go for it. Let's go. Way in the back. Yeah. Are there more? Are there more? Thank you. Happy Valentine's. Happy Blackbird. All right. So every single one of these is going to move up. So is that the X value or the Y value? Really quick. X value or the Y value? Y. So literally every single one of these points, move it up 4. So I'll do the first one for you, okay? If -4, 4 moves up by 4, I would get 1, 2, 3, 4. My new point would be -4, 8. And I will use pink. Okay, so I'll be here. That will be right here. 4 points from 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. I hope you can see that. Can you see that? I'll use a different color next time. Okay, so this would be f of x, the constellation f of x, with an extra 4. All the y values are added by 4. And this is also true for every function out there, okay? So keep this in my mental note. If you want to write it down somewhere, you can. If you see a function added to by a number on the outside, it's always going to go up or down, which means if I have a -5, what does that mean? Okay. Yeah. So this function is the dark line, right? Take every single point from this dark line, which is f of x, and go down by 5. So my first point, remember, it used to be -4, 4. This is -4, 4. 1, 2, 3, 4, 5. That point would be -4, -1, because I went down by 5. Bring everything down by 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 5. There you go. And this is the same f of x constellation, but -5. Okay, so I'm going to put a little note on the bottom of this sheet saying k value will vertically shift f of x up or down. Okay, for example, if k is equal to +4, right, is 4 units up. Here's an example, e.g. And some examples. I'm going to just write up a couple of examples, no matter how weird it is. If you see something adding way outside of it, it's going to be a vertical shift up. For example, well, some people are writing this. On the right column, I'm going to give you 3 different examples. I'm going to use a straight line. I'm going to use a parabola, and maybe I'll give you 4 examples. Let's pretend the function is x squared. How do I shift this up by 4? F of x would be x squared plus the 4, way outside. What if I had something weird? Like, what if f of x was square root of x, like something you've never seen before? Well, it doesn't matter. It's still the same thing. If I want to take this funky looking graph and shift it up, whatever that function is, on the outside, I just add by 4. That's it. Every single thing. Every time it's way outside of the function, if you're adding by a 4, it's going to shift up, it's going to shift down. All right? Any questions? We've already done one of the 3. It's one of the 3 you've done already. So if you have any questions, now is a good time to ask. Are you ready for number 2? Well, logically then, if we did up and down, what's the next logical movement? Right? You went up and down, what's the next logical movement? Left and right. So how can I get this graph, get this one right here, and move it left and right? That is going to be determined by H, the blue one. Turn the page. If there is a number subtracting or adding inside the function, and compare this with what we had before. Before we were adding outside of f of x. This one, the x is actually being changed inside the function. I'm going to use a blue right here. Please be careful. If it looks like it's subtracting inside the function, logically, what would you think is the direction of movement? If you're subtracting, yes, left. For reasons why that I can't explain right now, it's a very logical thing, and once you plug in numbers, it makes sense. But if it looks like it's subtracting, it's actually moving in the other direction. So I'll write this. If H appears to subtract, it is moving to the right. And vice versa. So ready? Remember, this point is -4, 4. And if I'm moving left and right, am I changing the y or am I changing the x? Michael, you with me? You might want to hold a pencil in your hand at least. Yeah, do your best. Take this. Negative, it looks like it's subtracting 4. We're actually going to move 4 units to the right. 1, 2, 3, 4. That is what? 0, 4. Right? So we have this 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. There. That is f of x minus 4. Please be careful. Please. So many people will make mistakes on this, and I'm going to call it out right now. I don't think this class is going to get perfect because I've never, in my history of grade 11, ever had a class where every single student caught that. But maybe it's possible this year because I am giving it to you as an assignment instead of a test. Please be careful. If it's inside the function like this, it's changing the x. Be careful of the signs. That's the next one. The function looks, yes, Marie. Yeah, sure. For everyone else, would you try to do f of x plus 5? Remember, the sign, if it looks like a certain sign, then it's actually doing the opposite if it's within the function. So if it looks like it's adding, then we must be shifting it to the left. Okay? Shifting it to the left. I'll give you a second. Okay? I'll give you a good minute. F of x plus 5. Sketch it. Right. That's 2. That's twice. Throw it away so it doesn't distract you. We're on the back page, by the way. Back of the first page. Thank you. Back of the first page. Okay. Let's see. That's good. Let's try it. So we tried moving to the right. Let me try like yeah, it's yeah. So we talk about up and down. This one is left. Yeah. Okay. Question. So A isn't the same as B. It's negative. For the K, it's as is. If it's a plus, then we're moving up as yeah. Yeah. Find Carter and come back. For the most part, I think it's pretty good. So again, we have 1, 2, 3, 4, 5. I'm moving 5 to the left. And so my point, notice that the 4, positive 4 doesn't change because I'm not changing the y value. This is negative 9, 4. That's it. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3. So my graph, if this was f of x plus 5, I will be shifting, I just shifted to the, I don't even have to think about calculations. I don't have to do any calculations. That's the beauty of transformation. The whole point of transformation is not to make your life harder. It's actually to make your life easier, that we don't have to plug in any numbers. We just slide it over. Okay, so to be true, k values, so h values will horizontally shift f of x to the, instead of left and right, I'm going to write right, left. Okay, so I'm going to, as an example, if it's to the right, it will be f of x minus an h. If it's to the, sorry, if it's to the right, it will be minus h. If it's to the left, it will look like a plus h. Sorry, like that. Let's put some examples down. And once the examples go on, I'm going to check to see if you can piece out this puzzle. We talked about what the numbers do if it's on the outside. We talked about what the numbers do if it's on the inside of the function. Can you do both of these? We'll just do the first one together on that curve. That's going to be our sort of in-class task for a second. So some examples. Some examples of being subtraction. If f of x was x squared, f of shoot, let me get some white out. If f of x was x squared, then that will be transformed into x minus 4 squared, x shifting it to the right. If f of x was that weird square root of x that I showed before, shifting it to the right would look like this. It changes the x value. What's the other example that I used? Oh, that's it. And it's moving 4 to the right. This is moving 4 to the right. Yes. So I was trying to demonstrate what an x minus 4 actually looks like. How do you change a graph? Remember, this is a parabola that we learned last year. It looks like this. If you see that the parabola shifted to the right by 4, like that, it would look like this in the equation. Okay, and you don't know what square root of x looks like, but just bear with me. Just pretend this is a picture. Let's pretend that's what the graph looked like. X minus 4, same thing. I've shifted it 4 units to the right. That's all it means. I'm going to give you a quick, maybe 3-5 minutes. 3 minutes is enough. Take a look at this one right here. I have a k value, and I have an h value. Can you draw me a function f of x minus 4 minus 5 on this graph? See if you can piece it together. clearly there are two different things going on. See if you can draw it. What do each of those numbers mean? And so what would the final look like? I highly recommend, I'm going to ask you this later on anyways, do each step individually. So start with the -4. What does -4 mean? Then do the -5 after you've drawn it. You'll see how I do it in a second. I'll give you a minute. All right, everyone, for the sake of time, I am going to go through the first one slowly, and then I'll do the second one quickly. -4 being the blue, it represents a movement, a shift horizontally, left and right. The -4 looks like it should be going left logically, but I can demonstrate a little later that if there is a -4 inside the function, we are moving to the right. So this point is going to be 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Now notice how I'm going to actually draw it in a dotted line because I'm actually not done. This is just f of x minus 4. What's next? That same function, it's not the only thing that's happening. There is a -5 also being applied. This -5 is not inside the function. It represents something else. What does it represent? A vertical shift down. So your final curve would be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Your final curve looks like this. It's right here, this one right here. One new math terminology, okay, one mathematical language. This dotted line right here, or this thing right here, we call it an intermediate step, like a middle step. That's not supposed to be there. So that's why it's like a dotted line. So I'm going to call this an intermediate step or a middle step. As we get to parabolas, I'd like you to draw me your intermediate steps very soon. All right. Before we go today, I need to talk about the third one, the very last one. So these are the two, right? Left, right, up, down. I need to talk about one more, which involves a multiplication. And then we'll call it a day where you can try practicing these at home, and we'll continue it tomorrow. It's really, really important that you know this because it's going to be evaluated in your little in-class assignment soon. And I go through these really quickly because it is supposed to be grade 10 knowledge, but a lot of you might have forgotten because of COVID reasons. All right, here we go. Turning the page. The very last transformation involves a number that could be multiplying to the entire function. Let's start with the examples. What would that look like? If my function was x squared, then you might have seen functions that have a number multiplying in front of it. If the function was that weird square root x that I was talking about, that will be transformed into just a number in front of it. It's multiplying. Okay, so what does that mean? I'll give you a 50-50 chance. Someone, a brave soul, take a guess. Do you think if it's this number is multiplying on the outside of that function, do you think it's going to talk about the y value changes or the x value changes? You have a 50-50 chance. Sage? It is the y value. What made you think that? It is outside the bracket, yeah. Another way you could think about it is, what is f of x again? Like if I had f of x is equal to x plus 5, it's a line. What's f of x represent? What is f of x? Yep. A function of x, which is also what letter? Not x, but the other one, the y, right? So if I'm multiplying f of x, that's like me multiplying the y value. So anything on the outside, we're essentially multiplying the y value. Take a look. If I'm going to multiply it by 2, remember, this is negative 4. Multiply that y value by 2. It becomes 8. I'm going to use my green. This is negative 4, 8. The y value of 4 was multiplied by a 2. Yes, Charlie. No, it was just a random equation, right? Right, so if that was this, which is the y value, if I said 2 times f of x, that's like saying 2 times x plus 5. You're essentially just multiplying whatever the y value is. That's why I want to show you that the y value originally was a 4. Now the y value is 8. This y value is, what is it, like negative 2 and 3? The y value was a 3. But if I am applying a multiplication of 2, what's 3 times 2? 6. Right there. So I'll write it down. That's a negative 2, 6. Ooh, the math doesn't change. This point is negative 1, negative 1. Take the y value and multiply it by 2. Negative 1 times 2 is negative 2. This is, what is it? 1, 2, 3, negative 2. Take that y value, multiply it by 2. Negative 4. I hope I'm just trying to set a pattern here, right? Every single number is doing something. If you can figure out what that something is, you're fine with transformation. It's actually really, really easy. And it's essentially free marks because there's no way to confuse as long as you know what each number is doing. Multiply by 2, multiply by 2. Take a look at what your new function looks like. Sort of like if any of you have worked with like Photoshop or any art programs, it sort of looked like a skewed picture, right? Or you're trying to put a picture inside Google Sheets or Microsoft Word. You take a picture and you're like stretching it in different proportions. Doesn't it look like it's been stretched in a weird way? That's why we call this a vertical stretch. Yes. Not the x, but the y value. So the positive 4 became an 8. The positive 3 became a 6. The negative 1 here became a negative 2. The negative 2 here became a negative 4. I think you get the point. So for these values, all you're doing is applying what we call a vertical stretch. It could be a compression, right? Or compression by a factor of whatever that number is. Sorry, by a factor of whatever that number is. And the rest of class is going to try to get you to practice using the vertical stretch. I am going to ask you to try some homework for me for tomorrow. I will be happy if you attempted like just 3 of these for tomorrow, but I'll get to that in a second. Let's do it one more time. Let's do it one more time. Here's an interesting one. What's my A value here? Yep. It's a -1. My A value in this case is negative. So every single Y value is going to be multiplied by a -1. So this is, again, -4, 4. If you take the Y value and you multiply it by a -1, it becomes 4 times -1? -4. Thank you. This now is -4, -4. Once again, this is -2, +3. If that 3 is multiplied by a -1. Oh, just repeat it?
Yeah.
Okay. So remember, if you are multiplying something to the entire function, what you're doing is multiplying that number to the Y value. And so take every single original plot on the function, take the Y value and multiply it with whatever number you have here. So this +4 is now a -4. This +3 is now a -3. And I'm going to go ahead. A -1 is now a +1. A -2 is now a +2. And a +1 is now -1, -1. What happened to my entire function? Well, we'll call it the x-axis. You're right. So in this particular case, we have a reflection. We flip it. So if it's a negative, what you say is there is a vertical reflection on x-axis. So every single letter is going to do something. You just need to remember what each letter is. And if you don't remember, where could you write it? On your study sheet. Just remember what each letter does to the XY point. Does it change the X? Does it change the Y? How does it do it? That's all practice. Yes, Cameron.
If you understand what it does, do you have to draw the graph?
Of course you do. Of course you do. Because most people, think about it, only mathematicians care what it does. Everyone else cares, well, what's the result? Finances. I don't care about the math. Tell me the result, right? Tell me what it looks like. Tell me how it changed. So it really is important to be able to communicate it visually. Okay. So I'm actually going to skip this last example. It will be available in your answer key. I want to demonstrate one of the examples on the back and then assign to you some of it for homework. Here we go. Here's the page. If you have some color, quick hint. Every single graph here, take a look at A, take a look at B, it's x to the power of 2. Take a look at C, x to the power of 2, x to the power of 2, x to the power of 2. Everything is x to the power of 2, which means we all came from this parent function. In pencil, or very lightly using dotted lines, I would like you to always start with this parent function to begin with. Remember all of our examples, we always started with the original function. That has to be done for the parabola as well. So remember, Draw the parent function. Some of you are asking, well, I don't know what the parent function looks like. You already do. If x was a 0, a 0 squared is a 0. If x is a 1, 1 squared is 1. If x is a 2, 2 squared is 4. And the same thing with -1. -1 times itself is a +1. -2 times itself is a positive. 0, 1s, and 4s. You already know. I'm going to plot it. 0, 0, 1, 1, 2, 4. -1, 1, -2, 4. You already know. Every single one of these boxes, I need you to start with this parent function. And lo and behold, these points will also help you. These 5 points are exactly like what I started with here. I gave you 6 points. This time we're working with 5 points. Right? Oof. Here, everyone, I don't have much time, so I'm going to say this in the last 20 seconds, literally. B and C. B and C is literally this. Let's see if you can do B and C for homework. We will do the rest tomorrow. Questions? Yes, Maria?